I'm going to tell you Taylor's theorem. Taylor's theorem. The Taylor's theorem states that there exists C such that C between A and X such that fx can be expanded into this polynomial and plus this term. So we call this polynomial the nth Taylor polynomial. n차 테일러 방식, and this remainder is called Taylor remainder. Okay. If a equals 0, so let's say a equals 0, then fx becomes f0 plus f prime 0 over 1 x and n plus n plus a f plus a. So a equals 0 is special case here, and let's say n goes to the infinity. N goes to infinity. So terms are increasing. Number of terms are increasing. So if n goes infinity, then f x equals 0. And it goes like this. And we define. Have you ever heard about Maclaurin series? Maclaurin series. Maclaurin series. Maclaurin series is defined as, so let's say Tx is defined as 0. And the number of terms are infinite, so this can be summed as This is Maclaurin series of f. Then can you say fx equals t? Do you think we can say fx equals the Maclaurin series of f? Do you? In fact, fx equals tx if the remainder. So let's say this is remainder term r and x. If r and x goes to 0 as x approaches infinity, then we can say fx equals tx. So fx equals the Maclaurin series. And so on. If the remainder term goes to 0 as x approaches infinity, then we can say f equals the Maclaurin series. Any questions? Then I will give you some example of the Maclaurin series. Maclaurin series is widely used in physics and mathematics, so it's very important series. Let's consider the sine function. So fx equals sine function. So we must check if it's differentiable and continuous. Is sine x differentiable? Yes, sine x is differentiable in whole interval. So differentiable at any point. And is it continuous? Yes, and sine x is continuous. Continuous. So we can find the Maclaurin series of the sine x. So what is the first derivative of sine x? It's cosine function. And second derivative, of course. And third derivative. And the fourth derivative. And sine x. And fifth derivative. So let's put 0. F0. F0 equals what? Sine 0. Each 0. Yes, 0. Degree. And f times 0. The 0 value, if you substitute 0 value here, then what is cosine 0 and each 1. And what is it? Minus sine 0. So 0. Minus cosine 0, so minus 1. So sine 0 equals 0, and f 0 equals sine 0 equals 1. We can do it as much as we want, but I will stop here. And if we find the Maclaurin series of fx, then and so on. So f0 equals 0, 0 plus the value of first derivative at x equals 0 is 1. So is 0 and and so on. So if we so this is the Maclaurin series of the sine x. Okay, then we want to know if it converges to the original function fx. Then what's the condition? If we want to say it equals fx, then what was the condition? The condition is that the remainder term approaches 0 as x goes to infinity. So remainder term is here. This is remainder term where c is. So in this case, a equals 0. So like this. Then remainder term is. Okay. We have to find the value of the nth derivative of f at c. But if you see here, can you see something in the derivatives of the sine x? If it differentiated, then it's cosine x, and if differentiated, minus sine x, cosine x, sine x, cosine x, it goes like that, right? So we can say f and x, right? Because the range of sine x is from -1 to +1 and right? So we can say the nth derivative of fx is between 1 and -1. So we can say the remainder term in this series is between x and +1 right? We can say so. Then what do you think will happen if n goes to infinity? What do you think those values will be? So we have two terms here, two things to think about: x n plus 1 and the factorial of n plus 1. What is n factorial? You multiply. Like that, okay? But as you might know, n factorial increases very rapidly. So it increases very rapidly. Equals what? 1 and equals and equals and equals and equals. So you see, it increases very fast. Then which term do you think will increase the faster? This one or this one? Which one increases faster? So x n plus 1 equal means you multiply x how many times? N plus 1 times, right? then which do you think will increase faster? This one or this one? The numerator or denominator? Denominator. This increases much faster. So as n goes to infinity, this increases very fast, and this increases slower than this term. So it goes to 0. And this one too goes to 0. Then what the value of the limit of R and X should be? 0. So you can say when we think about sine X, the remainder term as n approaches to infinity equals 0. And it means the fx equals to the Maclaurin expansion of the function. So fx actually equals to this series, 4 or x. So we can say the sinusoidal function sine x actually converges to the Maclaurin series of sine x. So it equals and we can use the sigma notation. How can we put it? Like this. So we expanded sine x into the power function. And if you do the same process, we can see actually the cosine x approaches to the Maclaurin series, which is equal to 1. You can do it at home and check yourself. And this is so cosine x can be expanded into power functions for or x. Any questions?
In 0 factorial is 1?
Yeah, we define factorial of 0 to be 1.
Can you verify that 1
Verify? Where we can think it's just definition, or you can find out the gamma function. So gamma 1 equals. This is the gamma function. You can find in the book which deals with the gamma function, and you can see why the 0 factorial equals 1. At this time, you can just think 0 factorial equals 1. This is just definition. Yeah. Any other questions? Then we can do another important function. can think about the exponent function with the base equal to negative constant. So namely fx equals ex, right? So as you all know, what is the first derivative of ex? Ex. And the second derivative? Yeah. And the third derivative? Yeah. It's the function whose derivative is always equal to the function itself. So if you differentiate it n times, then you still get ex. So if you put it 0, what is the value of the derivative, nth derivative? You put 0 here. 1. It's always equal to 1. So the Maclaurin series equals to but this value is always 1. So this is the Maclaurin series of Ex, and if you expand it, it goes like this. And we want to check whether the Maclaurin series of Ex equals to the Ex itself. So we must find out what the value of remainder would be when n approaches to the infinity, approaches infinity. So r and x. It's always x. So f plus 1, c equals e over c. So if take limit, what do you think that this value will be? So e to the c is just constant. And this increases much faster than the term here. So this equals to 0. So you can say actually Ex is equal to this polynomial for all x. So we so far found out the three Maclaurin series of three different functions: sin x, cosine x, and ex. And there is a relationship between sin x, cosine x, and ex. You can check out the relation among the three functions by considering the Maclaurin series of each function. let's consider EIX, where I equals to what? The root square of minus 1. So if we substitute minus ix to the x, then we can find 1 plus ix plus square root of ix over 2 cube of ix is ix, and go like that. And if you simplify it, you can check out by yourself that it equals to right. And if we substitute this time minus ix, then you can verify yourself that it equals EIX and E minus IX can be expanded into the infinite series, Maclaurin series. Then what about summing them up? So let's find the sum of the two functions. Then if we sum it, then 2 times 1, and those two terms cancels, and this so if we divide this by 2, so what is this function? This is the cosine function. So cos cosine function, right? And you can differentiate it. So let's differentiate it. If you differentiate cosine x, what is the derivative? What is the derivative of cosine x? Minus sine x. And if you differentiate this one, what is it? I e x. And differentiate this one? Minus I x. So if you multiply I over I, then it's EI. Multiply I over I and I, then minus EIX, and minus E minus IX. Right? So if we consider minus sign, then sine x equals to sine x equals to relationships between exponential function and sinusoidal function and cosine function. So we can obtain an interesting formula from these two equations, two identities. So let's multiply sine x by I, then I sine x equals to good. And equals what? So if you sum it, sin x plus I sin x equals to 1. If you sum it, what is it? E. This is Euler's formula. Great mathematician Leonhard Euler found out this formula, so its name is Euler formula. And you learned a lot of trigonometric identities, and you can derive almost all of the trigonometric identities from this equation. This simplification contains everything. You can verify some of the identities we have learned. Any questions so far? So if you substitute minus x to negative x there, then b sin x equals sin minus x sin minus x, right? So what is this term, the value of this term? It's even function, so it's cosine x, and this is equals to minus sin x because it's odd function. Then what about substituting pi over 2 here? So e to equals sine pi over 2 plus I sine 2. What is it? Cosine pi of 2 is equal to n equal to 0. And this equal to I. So this equal to 1, so it's I. So it is I. What about substitute this value to x. So e I pi over 2 minus x equals sine pi over 2. Then we can use exponentiation rule, so e minus x, right?
Yes.
Okay. Right? And this equal to what? I. So I, and this equal to this one. Sine x plus I minus I sine x. So equals I cosine x, and what is I times minus I? And the minus I squared equals 1. So plus sine x. So if you compare the real part and imaginary part, then you can find sine x equals sine pi over 2 minus x, and cosine x equal to sine pi over 2x, right? So this famous identities are verified. You don't have to draw right triangle and do the calculation. You don't need to do this. We just proved it analytically. And there are some other identities. Maybe one of the most important one is this one. So EIX equals sine x plus I sine x, and E minus IX equals sine x minus I sine x. So if you multiply it here, then EIX, E minus IX. So using exponentiation rule, minus IX equals to 1, right? So multiply it, and then sine x minus I sine x squared equals sine squared x plus sine squared x. So sine squared x plus sine squared x equals to 1. Right? This is another one. Very important and famous identity. And you can check out other ones. You can check out the addition formula. So let's say n beta is real number, and E I alpha equals sin alpha plus sin alpha, and beta equals sin beta plus I. And let's consider this term. Right? This is exponentiation rule, and you can just multiply it. Equals this equals sine alpha plus beta plus I sine alpha plus beta. You can expand all the sums, and you find you find this, and if you compare the real parts, those are real parts, and imaginary parts, then you can see that course right, this is the addition formulas we have learned. Any questions? And this is all I have prepared, and thank you.